Some people say NVIDIA is exaggerating a bit because of FB4, but they need to anticipate potential customer demands. In this fast-evolving tech world, overusing technical jargon can be a barrier for the general audience. There are numerous data centers already in place. These data centers need a complete overhaul. Hello everyone, Error here. Just 23 minutes ago, I saw that it was posted 3 minutes ago by the famous analyst Ming-Chi Kuo. You know who he is, right? Originally recognized as an Apple expert and analyst, he has built a reputation for his precise predictions about supply chains and forthcoming product announcements. Now, as his expertise expands to encompass the entire tech industry, this week he is turning his focus on the highly anticipated global tech event, NVIDIA's GTC 2025. I recently posted an analysis on the expected hardware developments and the future investment trends. While reading it during my workout, it occurred to me that with 2025 just around the corner, a flood of information is imminent, so I thought it would be beneficial to share some insights and predictions from this analysis beforehand. Why are these topics being discussed in this context? How will NVIDIA's AI hegemony evolve and what direction will it take in the future? I thought it would be good to share this in advance, so I'll see you next time. Even if I don't respond immediately, it's because I will soon be leaving for France and I'm not sure if I will be able to create content during that time. Anyway, since many people will be covering GTC 2025, it should help everyone understand better and gain valuable insights. Let's go through this together and explain the background in detail. If we examine the highlights, they appear somewhat vague, don't they? Nevertheless, to comprehend the background more thoroughly within the scope of our AI era, it's crucial to understand that the scaling laws will continue to be effective. So what does this imply? There are efforts to either replace LLMs or keep the existing transformer models, but to substitute the autoregressive models that many LLMs currently use, various innovations like integrating LLMs with diffusion models are being explored. The key question here is about scaling. If we significantly boost our computing power, will the performance improve proportionately? There are numerous questions and debates about whether this is the right path to achieving AGI, and if this is indeed the solution. However, it is evident that as the model size increases and more data is fed into it, the performance improves. Therefore, it is believed that this principle will persist, and as we advance, new developments will continue to emerge. Building an AI server likely means the B300 series. The Blackwell 100 and 200 came first. Now there's the new B300. I'll explain its specs soon. It's set to roll out in the second quarter. Test production starts then. Full distribution will be in the third quarter. There were many delays with the Blackwell. CEO Jensen Huang has addressed these issues. Although there were initial issues, the CEO confirmed everything is resolved. The supply will proceed smoothly. The B300, which I'll discuss later, shows a 50% performance boost over the B200. Its memory capacity has also increased from 192 GB to 288 GB. A significant increase has been observed. This likely indicates that SK Hynix's HBM is experiencing a surge in sales. This has been a topic of discussion for several months. The HBM sales for 2025 have already sold out, and there are ongoing discussions about the subsequent steps. This implies that everything is moving forward smoothly. Even with these geopolitical uncertainties stemming from both Trump's and Biden's administrations regarding the CHIPS Act and restrictions on China, NVIDIA took a strategic approach. They intentionally downgraded GPUs like the H100 to create models such as the H800 and H20 for export to China. This decision was driven by the fact that China remains a crucial market for NVIDIA. Since they are potential customers who can generate revenue, NVIDIA referred to this as uncertainty. But as I mentioned before, I switched the H100 to the H800. So while NVLink support and other specs are reduced, the HBM capacity, from this perspective, for companies in our country that supply HBM like SK Hynix or Samsung, they can continue selling the same volume of memory without any changes. Additionally, there's some discussion about entry-level and edge AI, and you might be wondering what that means. Essentially, you can think of it as smaller AI devices, right? They talk about AI PCs or smartphones, but I doubt NVIDIA will target smartphones. Currently, they are developing AI PC solutions like the N1X and N1, and there will be more discussions about these solutions. They want to show they are not just focused on servers because their goal is to provide solutions users can directly interact with as they have done in the past. Besides the services like LLM that they have offered, as mentioned earlier, there were some challenges with the GB200 and NVL70 servers. However, transitioning from the B200 to the B300 brings significant upgrade advantages, and major tech companies will definitely see marked improvements by switching to the B300. These insights could be quite impactful. Moving on to investment-related topics, it's crucial to delve into these aspects thoroughly. The most notable development in new AI server chips and system solutions is the B300, as highlighted here. The B300 stands out for its intriguing features. Does it support a dual die configuration? And as indicated, it also mentions CoWoS-L. Does it support a single die setup? It appears to accommodate both configurations. By utilizing dual dies, we can place two chips side by side in parallel, significantly enhancing computational performance. But the single die supports it too. The connection method is different. substrate. I've discussed server technology many times before, but to give a quick recap, it's about chip-on, wafer-on, and server substrate, right? Alright, we have chip-on, wafer-on, and substrate technology here. When we talk about server substrates, imagine those green circuit boards, similar to PCBs. On that board, various tiny components are assembled. We connect various chips to form a system, and in this setup, there are usually no interposers corresponding to wafers. Instead, the logical part simply connects the GPU, or attaches components like HBM DRAM, and connects them. While this should be straightforward, the signal lines provided by HBM are quite numerous, which adds a layer of complexity. There are an overwhelming number of connections that need to be made to the GPU, and to ensure these connections are established at an incredibly precise and fine level, they utilize a wafer, which is essentially made of silicon, strategically placed between the components. They have integrated a wafer capable of creating pathways at an extremely precise level, which is quite a breakthrough. This structure, referred to as chip-on-wafer-on substrate, is available in different types, CoWoS-S, R, and L. Specifically, the dual die configuration employs CoWoS-L, while the single die configuration utilizes CoWoS-S. To put it simply, this wafer is part of the chip-on-wafer-on substrate setup, which also includes a silicon interposer. So, what exactly is used for this type of wafer in this scenario? The most traditional method is to use the front-end process I mentioned earlier to create the silicon interposer, but as I said before, it's like making this chip. Just like how a wafer is precisely manufactured in a semiconductor fab, this process involves extracting it with extreme precision. This diagram that I often share will give us a clearer picture. As chips get larger, producing these circular wafers in a fabrication plant becomes increasingly challenging, demanding the highest levels of accuracy and efficiency. Let's say they produce about 50,000 wafers per month. No matter how big or small the chips are, they can only produce 50,000 wafers a month. So the smaller the chips inside, the more chips you can get from each wafer. This absolute quantity is important, and the same goes for the process of making these wafers. As a result, the yield rate decreases significantly. On top of that, NVIDIA's GPUs are already massive, and attaching multiple even larger HBM chips to cover such an extensive area makes the process even more complicated. The fabrication plant has to produce these huge interposers every single time, adding to the overall complexity and difficulty. They have to produce these on a large scale. Only a few dozen can be made per wafer. That's why cores are a bottleneck. If a particle sits on it, the yield won't be good. So even if they want to make more HBM, they can't. The yield is too low. And since these cores are a bottleneck, production can't start. Wouldn't they want to replace it with something else? The alternatives that were introduced are CoWoS-R and CoWoS-L. However, if you look closely, CoWoS-R and CoWoS-L are not present, only CoWoS-S is available. CoWoS-S, known as the single version, utilizes the traditional interposer method. Meanwhile, CoWoS-L has been developed to incorporate TSMC's InFO technology. At the current GTC event, the Core R, which is not expected to be announced, will replace the silicon interposer with a fan-out design. To put it simply, you can search for Andel Engineering Interposer for detailed information, but instead of using that, they are opting for something called CoWoS-L. So, what is this exactly? TSMC has InFO tech. We call it fan-out wafer-level packaging. But what is CoWoS-L? TSMC has another technology called InFO, which we refer to as fan-out wafer-level packaging. They use CoWoS-L, which incorporates silicon in a manner similar to Intel's EMIB, connecting different silicon parts together. This design leads to a dramatic increase in HBM, enhancing performance by 50%. However, this is still based on FP4. FP4 isn't widely used, but they packed a lot of logic into it. They likely added many cores and transformer engines. This caused a slight slowdown in the growth of 16-bit and 8-bit standards. It seems they are marketing something new with FP4. As mentioned earlier, they will start pilot production of EQ soon, at a scale of 3 kilograms. Some people argue that NVIDIA is being misleading due to FP4, but that's only half true. While it might seem deceptive, we have to remember that NVIDIA is fundamentally a hardware company. When they present their hardware development plans, it usually takes about 2 to 3 years from initial design to final production. You need to anticipate the potential future demands of your customers well in advance. So, did the AI model DeepSeek come out a year ago? DeepSeek wasn't available then. Reinforcement learning was still in its early stages. There wasn't much focus on it. But suddenly, the world changes. If you prepare the hardware at that time, given the unpredictable nature of technological advancements and algorithmic changes, it's crucial to have hardware ready ahead of time with FP4. There are already instances where even sub-2-bit precision yields impressive performance, as evidenced by recent research. To stay ahead and differentiate from competitors, we must be well prepared with FP4. I think it's a reasonable idea. In the export market, FP4 is widely used. NVIDIA might be trying to block others from capturing that market. This is an insight worth considering. Meanwhile, the GB300, like the Blackwell 300 series with Grace CPUs such as the MV72 version, HGXB300, and NV16 these systems are all air-cooled, right? They produce a tremendous amount of heat. I've compiled all the details about different cooling methods such as liquid cooling, immersion cooling, and air cooling. You can can easily find this information by searching. To put it simply, cooling capacity refers to how much heat generated by the power can be dissipated with just a fan. You can use a fan to cool it down, or you can use a special liquid that quickly absorbs heat and releases it outside. There's even immersion cooling, which in English is called immersion cooling. It wasn't mentioned here, but liquid cooling involves submerging the chip in a specific liquid. This liquid is non-conductive, meaning it doesn't conduct electricity. You can use it instead because it absorbs and releases heat quickly. However, the challenge with immersion cooling is that it requires a complete overhaul of the data center infrastructure. All the servers need to be submerged in a special non-conductive liquid, which means significant modifications to the building itself. Currently, we primarily use air cooling or liquid cooling methods, and while people often refer to it as liquid cooling, I believe it's important to standardize the terminology we use in Korea. Personally, I think the correct term should be liquid cooling, and we need to ensure that our technical terms are clearly defined and consistently used. Simply calling it liquid cooling might cause confusion with traditional water cooling methods. So it's important to clearly define these tech terms as they emerge. As I mentioned before, when using AI models like recent diffusion models for reasoning tasks, you might input a query. The system processes it, which can sometimes result in discarding irrelevant information. It involves the process of thinking and then continuing to think while engaging in that thought process. In Korea, this was translated as an inference model, but it's worth noting that the term inference had already been widely adopted and used within both the AI industry and academic circles for quite some time. We have been referring to the process of using an AI model after training as inference, whether it is for training purposes or for performing inference tasks. And if we start using the term inference model for listening as well, I believe there could have been many alternative terms such as thinking model or other descriptive names that we could have adopted instead. It's a bit unfortunate that it wasn't utilized in the same manner, as it would have been beneficial for tech channels like mine. It provides content for discussion, and I appreciate those who engage with my commentary. I'm continuously learning as well. However, with the rapid pace of technological advancements, indiscriminate use of terminology makes it challenging to connect with a broader audience. Therefore, we must be careful when defining these terms. That was an unnecessary comment. That's why I suggest using the term liquid cooling instead of immersion cooling. I will dive into the details behind this choice shortly. Next, we're also preparing workstations, and we'll talk a bit about Vera Rubin. They are discussing the configuration. Once the details are out, we'll delve into them more. Products like the B300 and MV72 are already being talked about. These are pre-built samples, commonly called PS. They are expected to be ready by June. These samples are in the initial testing phase before mass production, so they are not yet fully completed. It's not fully developed yet. They will distribute it to clients to try. They might send it to Elon Musk or Satya Nadella. They'll ask, want to buy more this time? As we look forward to GTC, what is referred to as VR actually stands for the Vera Rubin architecture. Think of it as the next generation after Blackwell, featuring a blend of the Vera CPU and Rubin GPU. Initially, the setup consisted of 70 racks, but it has now expanded significantly to 288 and 144. You can see it, right? At this point, we might really need to move towards immersion cooling. Anyway, the talk is about when production will start in small volumes. It's expected to be around the summer or fall of 2026. That's when they plan to announce it. Next, for workstations, it will be the RTX series. These use GDDR7, so our domestic memory companies, especially in the case of GDDR7, it has been reported that NVIDIA is currently collaborating with Samsung Electronics. Although it may be lagging behind in some areas, the demand for GDDR remains quite strong, especially in the workstation market, which, while not enormous, still holds significant importance. And finally, I cannot overlook mentioning the Quantum series data center network solutions, including Quantum 3, Quantum X800, and Spectrum 5. All of these devices are fully compatible with PCI Generation 6, also known as PCI Express, which is a crucial standard that facilitates efficient communication between various chips inside a computer. For instance, when the CPU and GPU need to exchange data, they adhere to a specific protocol that ensures smooth and reliable communication between them. Are listening in Korean, and those tuning into the English version are hearing it in English. By knowing the rules of our language, we can communicate effectively. Similarly, when transmitting data at a certain speed, we agree on the modulation method. This is the principle behind PCI Gen 6. It is expected that these features will be supported. Although Ming-Chi hasn't provided in-depth predictions, it's anticipated that several new chips will be launched in the network sector. These efforts are part of NVIDIA's broader alliance, which aims to support various PCI-based specifications, including those from Broadcom. NVIDIA is expected to showcase their prowess in handling network companies, emphasizing their strengths in this domain. Another major focus will be on quantum computing, as the GTC 2025 event will feature numerous leading quantum computing firms, including Rigetti, IonQ, and D-Wave, who will present their latest advancements and insights. These days, hybrid computing is really making waves, isn't it? Another exciting point is how quantum computers are now speeding up certain tasks that were traditionally done by classical computing. So, So, who's backing this? Well, it's NVIDIA. They've been on this for a while with their CUDA quantum system. They're now enabling support for it as a comprehensive platform. These kinds of topics, along with the usual discussions on robotics, are something we can look forward to, and I believe there are aspects worth mentioning here. Today, I shared a variety of topics in a rather unorganized manner, as this wasn't a planned content and I was just exercising, which made it difficult for me to explain each background element in detail. There are many instances where I fall short due to my limitations, but I thought it might be good to have a segment where I slowly go through and explain things in an unstructured manner. After all, how much can I really know? Even though I am a YouTuber deeply interested in this field and I strive to grasp it thoroughly, I know I have my limitations. If I miss something, please let me know and share your in-depth knowledge. I also try to explain things in a way that is accessible for those who might not be familiar with these topics. Thank you for understanding. For those who find it easier to listen in English, please tune in to our international channels. I also post brief updates on Instagram. And finally, it's time to wear this hoodie. The weather has warmed up and the hoodie that Yoonhee is wearing is made with excellent quality. I appreciate your support. This has been Error.